Alright, you'll have methods looking now at one-to-one functions. We've looked at a whole range of things here in this section, set notations and relations, what makes a function, domain range. Just recapping what makes a function, and that was the definition of a function is a function that has a maximum of one output value for each input value. So for each value of x, there can only be one value of y. We can't have any doubling up vertically. So we would look at a vertical line test to test for functionality. What we're going to look at today are functions that are one-to-one. One-to-one functions have the characteristic that for each y value or output value, there is only a maximum of one input value. So that means it's the opposite of this the functionality test. For each value of y now, so we're going to take a value of y, there has to be a unique value for x. Well, for that value of y, there are two x values, there and there. So this function here would not be one-to-one. Now the definition is written down here. One-to-one functions are functions that have a maximum of one x value for each y value. The test for a one-to-one function is a horizontal line test. If the horizontal line intersects with any horizontal line, if any horizontal line intersects with the graph of the function more than once, then the function is not one-to-one. Now, what's the significance of that? I hear you shout. The significance is that a function has to be one-to-one in order for it to have an inverse function, or in order for its inverse to be a function. Now, to find an inverse, you reflect the function in the line y equals x, because the process of finding an inverse function is to switch all the x and y coordinates the other way around. So for y equals, if you've got coordinates 4, 1 on a function, then on an inverse function there'll be 1, 4. Every ordered pair gets switched around. So what happens is, this is f of x, f dash x, it will look like, it will reflect in y equals x. So both these branches reflect in y equals x. So it would look something like that. So failing the horizontal line test means that its inverse will fail the vertical line test and therefore not be a function. That's the significance of one-to-one functions. So horizontal line tests whether a function is one-to-one, so you need to be able to establish that. And we are going to, in a day or two's time, look into inverse functions, and this will probably make some more sense at that stage. So let's have a look at a couple of functions and test to see whether they are one-to-one. This is our old favourite y equals x squared, or f of x equals x squared, and clearly that is not one-to-one, which means that its inverse is not a function. We've just looked at it there. Its inverse will be on the side parabola. Clearly won't be a function. However, we could be very clever and define it just over a domain that means it does pass the horizontal line test. So I could say that x is only defined from 0 to infinity. Therefore, it's just this part of the y equals x squared curve. It passes the horizontal line test, its inverse will look something like this. So its inverse will be a function. So things like that happen in order to make functions, or domains are often restricted on functions that don't pass the horizontal line test. So they do pass it. Typically parabolas are very easily done just by taking half of it. In that way you can ensure that the function is one-to-one. The inverse function. The inverse is a function. A restricted domain can lead to a function passing the horizontal line test, therefore becoming one-to-one, and therefore having an inverse that is a function. Okay, so an unrestricted domain here, doesn't pass the horizontal line test, therefore its inverse isn't a function. Restrict the domain, now it does pass the horizontal line test, it is one-to-one, and its inverse is a function. Okay, other examples, we could look at the exponential curve. Clearly that is one-to-one. There is no person. So it can have 0 break, 0 points of intersection, just can't have more than one. It's one-to-one. Straight lines, one-to-one. These will all have inverse functions. Okay, so I'd like you to go to page 178, 179 and do exercise 6G from the work requirements. Sorry, that's incorrect, for 6D from the work requirements. Hopefully you'll be able to get through that no trouble, and please check back tomorrow night for the next installment of YouTube videos. All the best, see you later.